Hey, so this is a video that goes over the solutions to problems 6 through 10 on the random gas laws worksheet. So again, on these problems, the first thing that you want to do when you look at a problem is determine, like, is there some change that's occurring or is there not? All right, so if I read this problem, how many moles of gas does it take to occupy 120 liters at a pressure of 2.3 atmospheres and a temperature of 340 Kelvin? Notice there's no change going on, all right? You just have all of these different properties, and it's asking you to find one that you don't have, which in this case is going to be moles. All right. So the equation for that is going to be PV equals nRT. All right. So since we don't know N, we want to get N all by itself. So we do a little bit of algebra. And that will give us this right here, N equals PV over RT. All right, plugging in our values, we're going to get this expression right here. Again, when you're plugging in your values, it's a good idea to just put everything in parentheses. So where there was a P, put that entire pressure in parentheses there. Where there was a V, put that entire volume in parentheses. All right. So, by the way, one thing I didn't mention is your R value. Remember, you have 3 choices for R. You want to find the one that corresponds to atmospheres because we have atmospheres as our unit of pressure there. All right, we are then going to solve that problem, which this would be the rough number that comes out. And if we look at significant figures, you can see that this says 2, this says 2, this says 3, and this one has 2. So we want to round that to have 2 significant figures. So it would be 9.9 moles. All right. Again, I know that's different from the answer at the bottom of the worksheet, but if we're paying attention to the significant figures, this is the way it should be recorded. Okay, so when the temperature of a gas changes, its volume increases from this to this. All right, so right off the bat, we can tell this is a problem that involves change. All right, so we know it's going to be some variation on this. All right, so if something does not change from start to finish, we can take it out of the equation. All right. So in this problem right here, it mentions temperature and volume changing, but it doesn't mention anything about pressure or the amount of moles. So we can just take pressure P and N out of this equation, and we get this. All right. We want, since we don't know T1, we will do a little algebra to get that all by itself, giving us this. And, well, actually, we're going to first crisscross this so that we can get rid of the denominator. And then to get T1 by itself, we do a little algebra to get this expression right here. Plugging in, we're going to get this expression right here. And notice you have it so that your units of volume match, so that that way when you do the math on it, they will cancel out. This pops out first. We're going to round it to that. But then notice that the question asks us to give the answer in Celsius. So we need to turn that value of Kelvin into Celsius by subtracting 273 from it. All right. In the next problem, again, this is one that involves some type of change occurring. All right. So we know it's going to be some variation on this. Everything changes in this problem except for N. All right. It does not mention anything about moles. All right. So when we do this, we're just going to take the N out to give us this expression right here. All right. We want to know what the final volume is. So we're going to rearrange this to get V2 by itself. So first of all, we're going to cross multiply to get rid of any denominators. After we cross multiply, we can get V2 by itself, so that it would be this right here. All right, we are going to then plug in to give this expression right here, and then we are going to solve for that. And notice when you do this, everything cancels out except for liters. So that's what the unit of our answer is going to be. All right. And so in terms of significant figures, notice that you have some of these that only have 2 significant figures. So that's going to dictate the amount that we have in the answer. In question number 9, we have some change that is occurring. So we take a look at this right here. It does not mention N changing, and it does not mention temperature changing. All right, so we can take temperature and N out. So that's going to give us P1V1 equals P2V2. All right, rearranging this to get P2 by itself. All right, we're going to get this, which we can then at that point plug our numbers in. All right, so we're going to get this right here, and then we are going to do the math on that. This is what pops out of the calculator. But since there's and one thing I failed to mention, I went ahead and put a decimal after these values right here. I know that doesn't have that in the original problem. The reason that I put that in there is so that those would have two significant figures. All right, so that when we now round this, we're going to have we would round this to 2,300 millimeters of mercury. All right, so in question 10, the last problem, again, we have some type of change going on. So it's going to be some variation on this. All right, so in this one, we have pressure changing, we have temperature changing, but nothing else. So pressure and temperature change, so we're going to get rid of volume and N. All right, so it's going to reduce to this. Again, we're going to do the same trick. We're going to cross multiply. Again, that gets rid of the denominators. All right, and then we're going to get T1 by itself. All right, so actually we're going to get T2 by itself. T2 is the thing that we don't know in this problem. So getting T2 by itself, we have this expression right here. Again, that's just applying a little basic algebra to this equation right here. Plugging in for what we don't know. All right, we get this right here. And notice that everything cancels out except for Kelvin. We get this right here. And then we round it to, in this case, 3 significant figures, because everything here has 3 sig figs. So we would have that as our final answer. Okay? Thanks, and good luck with studying.